What are you going to go through and do, Corey, to work towards an answer in that first question?
You can sub in 51,200 for B.
Okay. So we get to here. Now, before I go into answering this question, I already know what this question most likely will involve. Who can tell me what math idea that we've covered this year that this question will most likely involve and why? And this is the things that you should be anticipating what's coming forward, because there's only so many ways we can ask these questions. What are you anticipating that this question is going to use, Philip, and why? Why? Yeah, we need to go through and solve for a variable in the exponent spot. Now, we may need to use logs. We're not guaranteed that we have to. Looking at this, what would your first step be? Sean, Al, what would you do? Divide both sides by 100. Hopefully we don't need a calculator to do that. The zeros are going to drop out. So you've got 512 is equal to 2 raised to the t power. This is actually one maybe some of you can do without the calculator. But let's get in the habit of writing this out into, well, how would we go forward from here? Grace?
I put it into log form.
Okay, what's this going to look like in log form?
Log base 2 and log 14.
And then what is the value of log base 2 of 512? Con, what do you say? 9. Now, if I stop right now, I'm wrong. Why? So, how many minutes would it be? Well, you'd have to take 15 times 9, and what do we go through and get on that? Hands up, please, when you can tell me. Yeah. 135 minutes. Now, let's say you get stuck. Well, actually, I'm going to tell you this right now. Here's one reason this probably won't be on there, and if it is, it will say algebraically. Go back up to the original. We could get an answer immediately at that point. How? How can I get an answer? You're sitting there in June, and you go, before I do any of this, I know what the answer is going to be. How would you know what the answer is going to be right away? Tom? Now, you could randomly plug in numbers, but understand this. In terms of this, and you've had people that have told you before that guess and check is viable. Apparently the Regents takes it. You'll never hear me endorse it, number one. It does give you a ballpark, though, of where your answer is going to be, but I can know exactly what the answer is without taking some guesses and checking them. I can know what the answer to this is immediately. How? Okay? To do what? Yeah, by doing what? We say, hey Siri, what's the value of this? Wouldn't it be great if the calculators came with Siri? What do you want to say? Yeah.
Just point it in and then do bar t equals that, and you'll know.
You could check your answer by doing that, but there's another way we can do it instantaneously without having to even guess. Numeric solve. You can use the end solve on the original equation and go in right now, all of you, type that into your end solve. And what is it under? Is it under algebra? Because there's one in there too. Remind me, when we get a 3x3 system, one of the reasons that the state is probably not going to ask you to do a 3x3 system anymore is because there's an algebraic system solved that works on 3x3, 4x4, yada yada. Now, when we get there and you type that in, you type in the equation, comma, t, and is that going to solve it, or what do you get as your answer? We'll say that. 9. So you want that second, if you're the state, why do you want the secondary step in there? You tell me, why do you want that second step in there? To make sure you've read the problem. It's 9 cycles. Each cycle's 15 minutes long. Questions on that? All right, take a look at the next one. We need to find the roots of this equation. So, Amanda, what would be your first step? So we've got x squared minus 2x plus 7 is equal to 0. Now, at this point, this will not factor down. There's no numbers that multiply to 7 and add to 2. However, we've got 2 paths still left to get an answer. Hands up when you can tell me one of the 2. Seriously? Oh, come on. You must want a new teacher because you're trying to give this one a heart attack. Can you imagine how nice that next teacher you get is going to be? How are you going to solve it?
Quadratic equals.
Who can tell me? We'll use plot because that's what he said. You can tell me another way I could get the answer. Come on. This question actually sets up nicely for him. Riley? Complete the square. The conditions, either one is going to work. Completing the square always works the most efficiently when you have to have a lead coefficient of 1 and your middle value has to be even. That's met by both of them. So we've got two ways. Thomas, we're going to do quad formula like you said. Here's the shell of the quad formula. What goes here?
2.
Here.
2.
And here. Did you do it?
20.
No? Hands up, please. And I already know, by the way, it's probably not going to be 28. Hands up, please, if you can tell me why. What's on here that lets you know it's probably not going to be on 28? That the discriminant's not going to be 28. Yeah.
It says plus A plus BI. It's got to be negative.
What's negative? Don't say if. Yeah, the discriminant, the value under the radical is going to be negative. Go in right now, all of you. Parentheses around the b value, squared, minus 4 times a times c. Go in and do it. Don't wait to be safe. And Riley, what value do you get? So we get to a negative 24 here. Now, and I'm going to chain these together. I think that you can do this as a linked value, meaning that you don't have to keep rewriting out x equals. Looking at this is going to be 2 plus or minus something over 2. What's the square root of negative 24 going to simplify into? What's the square root of negative 24 going to simplify into? What would you go through and say, Nick?
4, 6.
Yeah, and then the square root, what's the final simplified value going to be?
Oh, it would be 2 plus or minus 2i or 6.
I'm not taking that as a final answer either. Hands up, please, if you can tell me why. Go ahead. And yes, if you need to put it over 1, you can. But that's your final answer. I believe that this linkage or chaining like this is permitted. I think in the Math 8 they stopped letting it happen, but in high school you still can. By the way, go into your calculator right now and try this. Try and put it in as a poly roots. Remember we did C poly roots the other day? Now, hang on. Let me do this because I didn't set it up yet. Now, you said something and you said something that both are good. Did you do C poly roots on it? Yeah. Okay, so when you did that, how many roots did it give you? 2. So, and you're saying, I'm guessing the format then would be 1 plus some decimal and then an I. Now, you said something though to build off of his because you might look at that and say, I did it wrong. How would you know that you did do it wrong if you got, what was the decimal you got? 2.449, yada yada. What did you say? There you go. The other end, so that's going to help you get to the answer. The other end of it is to check to see if you did this right. Literally plug it in. Is it equal 0? Do the bar. X equals. There's no plus or minus one, so you just do 1 plus and then 1 minus to go through and make sure that they both work. I don't think we need it for today. I'll try sign in right now while we're waiting. If I need it, we'll use it, but I don't think we will. Take a look, loves, at the last question. If that's the relation, which of the statements is true? Well, you need to be able to unpack something before you answer this question. What do you need to know before you can answer this question? Take a look at what's there. What do you need to know before you can answer this question? I've got one person. You need to know something before you can answer this question. And if you got stuck, it's probably the thing you don't know what it means. What's the part on there that you're getting sort of test on? Go ahead. We know that part. That's, I guess, a more broader understanding because that's a Math 9 topic. Yeah, you've got to remember that anything with that minus 1 after it means the inverse. Now, there's 3 tenets of the inverse that you've got to know. What's one thing when you see inverse that you've got to be able to remember? You tell me. We're going to build up all 3. Just one. Go ahead. Perfect. If you're given an equation, you switch the x and y, and most times solve for y. What else do we need to know? That's 1 out of the 3 things. Go ahead. A comma B becomes B comma A. And what's the third thing about an inverse that we need to know? We got one person. Do you remember? Perfect. Over the diagonal y equals x. This is a set of points. So what is a point on the set A inverse going to be? We just got Nick. Panic, what's 1 point on A inverse? I can't hear you. 2, 3 is a point on the inverse. What's another point on the inverse, Anthony? What's that? What's another point on the inverse, Megan? And then the last point on the inverse would be 4, 7. Now, I already know the answer to this question, and I actually knew it in the beginning. What answer would we go through and select? Philip? And what's 1 say? No. 1 is not correct. 1 is not correct. Yeah. Why is 3 the answer?
Because A inverse has 2 has 12.
There you go. One input has multiple outputs, and that one input that has multiple outputs is a 2. Does anybody know how I knew the answer to this before I even did it out? It has to do with something we touched on before. Do you remember? Do you remember what that's called if multiple inputs share the same output? That means it's not a one-to-one function, which means if you graph it out, it will pass the horizontal line test. It will not pass, it will pass the vertical line test. It won't pass the horizontal line test. That's how we knew immediately. Now, we have a ton of stuff that we need to go through and cover today. We got through up to this last time we had class. So we left off on page 21. We constructed out a tree diagram based on what was given. We constructed out a tree diagram based on what was given. And it says what percent of the company's policyholders are expected. So this was the diagram that we went through and made. You have that on your paper somewhere on page 21. Is that correct? Okay. So we answered question B, which you'll obviously need to know how to do. We did not answer question C. Find the probability of something given something. So looking at this is the part that's going to be a little bit awkward for us. It's going back and doing that given condition. Remember, when you're talking about and when you're talking about what these probabilities are, you have to understand, and this is something that we can't teach you except repeating it over and over and over again. There's 2 ways that probabilities are computed. There's something that's done directly, and then there's a conditional one, meaning something has to happen first, then a second event has to happen. If that's the case, you do the bar there, where it's the probability of B given A has happened. So if I went through right now and said, all right, what's the probability of choosing a girl in this room? The answer to that is going to be different than what is the probability of choosing a girl given you're looking at the people in the first row. There's an initial filtering that's done, which is looking only at the people in the first row and then taking the probability out of this as opposed to looking at the whole group. Looking at this says find the probability that the person is under 25 given they had an accident. So, what is the first criteria that you have to meet in order to be part of this? Or what's your first exclusionary characteristic? Go ahead. People that had an accident, so all of those people are going to go to the side. And then from that group, I'm going to walk over and say, oh, okay, out of all of you, how many of you are under 25? So let's start off with the probability of having an accident given you're under 25. So it's the probability of having being under 20, well, I'll say 25 minus maybe, given, because we already have the given there. and that you had an accident over the number of accident people. So we can compute right now the total number of accident people. You actually did it above. What's the probability of the accident people overall for everyone that this company insures? What's the probability of an accident overall for everyone that this company insures? Really? You already found it. Read question B. Go ahead. 0.0441. Now, how do we find the probability that the person had an accident and is under 25? Well, what would we do for that? Yeah. Yeah. Close. There's more on there than just the point, because the point 11, oh, I went back, sorry. The point 11 is just the number of group A that had an accident. So we need to do something to that point 11 as well. How do we get to that end point? What else did we not factor in?
0.22.
Remember, it's got to be both ends get you to the total probability of the people having both. So this would be 0.11 times 0.22. Go into your calculators right now, compute that out. So what's the probability that someone who had an accident is under 25? Hands up, please, when you can tell me what that probability is. Yeah.
0. We're going on.
Let's go to 100th position.
0.05.
Nope. I got something different when we did it, isn't it? Did somebody get something? It's not 0.05. Shouldn't it be 0.55? Did I do that right? Okay. Now, and by the way, just so you know, these numbers are actually real. So you people wonder why young people, you all, if you're not already, will be paying a substantially high amount for insurance. Like when I first started driving, my parents wouldn't let me on their policy in spite of the fact that I drive like I'm an 85-year-old woman. A lot of things I do already. But I drive like an 85-year-old lady. My insurance premiums for 6 months were $2,800. For 6 months of driving. That's it. Just to have insurance. So understand, what does this mean? You tell me, what does this 55% represent? The likelihood of what? Two people can interpret that? That's the part, in all honesty, that gets concerning. You just got an answer. Now, pardon the language, but what the hell does it mean? Go ahead. Our what? There you go. There you go. Now, we did this already. Yeah, we'll do out 3, and maybe then we'll go. Yeah, 3 is good. We're hopefully going to finish everything and then go back and do some more. So take a look at question 3, because 3 really marries together that notion of, is something going to have to happen first, or are these just a straight up probability of an event occurring? So take a look at 3A. We're going to go through and draw a tree diagram that represents this situation. So that's your first step. Go through right now, draw a tree diagram that represents it with the probabilities on it. So go in right now, draw a tree diagram that represents the situation, and get the probabilities on it. So here's what the tree diagram itself looks like. Let's start throwing some probabilities on there. What's the probability that with our first pick, we get a lemon? Tom, what do you say? I don't need it reduced. 16 out of 36. So you do 16 over 36 on that one. What's the probability of getting, what's the other one? Watermelon? McKenna, what's that going to be? And then the probability of getting a raspberry, Sean K, is what? All right, so far that one hopefully is easy for you. Now, the next part is you're taking a second jelly bean. So, you get a lemon the first try. What's the probability you get a lemon the second try going to be? This is place yourself in the situation. Analyze. Engage. We've got 5, 6 of us that can count it. Ben, what do you think? Careful. You've gone in, you've got this jar in front of you. You close your eyes, take out a lemon first time. Now you're making a second pick. What's the probability that that second pick, just the second one, is a lemon? It's not going to be the same. Be careful because you're ignoring what you did before, you know? 15 out of 35. Why is that the case, then? Did it say you're putting it back in after you take it out? You ate it. It's not coming back out unless somebody... Yeah. Yeah. No. It's off of the lemon. See how it's that first condition? This is a lemon, then a lemon. You see what I'm saying? It's going to do what you said on the other 2 branches for lemon. Now, what's the probability of getting a watermelon on your second pick? Hands up, please, if you can tell me that. Go ahead. 12 out of 35. And then this one would be 8 out of 35. What's the probability of getting a lemon after you got a watermelon? Hands up, please. Yeah. You know? Take a look. What's the probability of getting a lemon if the first one you pick is a watermelon? 16 out of 35. Getting a second watermelon would be 11 out of 35, and then a raspberry would be 8 out of 35. Over here, this stays 16 out of 35. Next one, watermelon, is going to be 12 out of 35, and then the raspberry is down to 7 out of 35. Questions on why those are, and they're good questions. The problem that you all have had for so many years is that you get put in these classes and they keep going, just regurgitate everything that I said. Well, frankly, and it's a gross image, I don't want you regurgitating watermelon, lemon, or raspberry jelly beans. But you do need to think. Now, what's the probability that someone eats 2 jelly beans? Now, this one's a little bit awkward because you could do it as a given. Something given something. You're looking to find the probability that I go through, get a lemon, go back, get a second lemon. You tell me, how would we go about computing out what that is? Because I'm going to tell you right now, it's not going to be a given, something given something. At least that's not how I want to do that. How would we compute that? Want to get back?
So you take the first probability, which would be 16 out of 36, and then you take the second probability, so it would be 16 out of 35.
You're trying to find the probability of a lemon and a lemon. So the first probability is 16 out of 36. The second probability is 15 out of 36. You go through and multiply. Go through right now. Type that in your calculator. What's that going to go through and give you? What did I write? 36. Sorry, it's 35. Yeah. You tell me, what is this going to compute out to be? Hands up. We'll wait for 6 of you that can tell me what this probability is going to be. Got 1, 2, This is why, and I don't worry about reducing, because if you type something in the calculator, will reduce it. So we're not fine. Fraction. 4 out of 21. This is just a straight up this given this. Lemon and lemon. Next one. What's the probability that they go through and eat a watermelon and a raspberry in either order? So this is going to be an interesting one to go through and do. You need the probability of someone eating a watermelon and a raspberry in either order. So what's something we would need to compute in order to arrive at our answer for this? Do you want to try? Go ahead.
The probability of eating a watermelon and a raspberry.
So probability of watermelon and raspberry. What else do we need to compute out? We got one person still. Come on. Come on. Yep. So probability of a raspberry and a watermelon. Now looking at that, what am I going to have to do to those two probabilities? Add them together. So now, how would we compute the probability of a watermelon and a raspberry? John, what would you need? Plus, now we need to compute the second half of this. And Kirsten, what's that going to look like? Go into your calculator, you can do this all at once. Another thing that you all need to keep in mind, if the condition is saying and, you multiply. If it's an or, you add. So technically, really what we're having right here is this. There are two different conditions. This condition or this condition. Remember, when you see an and, that means multiply. When you see an or, that means add. So what value does this come out with as your final, Sam? Questions on that? Notice those are not conditional. However, this next one is. If the first jelly bean selected was lemon, what's the probability that the second one will be lemon as well? Now, there's a direct way that you can get this, but I'm going to walk it through as something given something. You're taking the probability, in this case, of what given what? You tell me. We've got one person. Because there is an initial filter is done on this. The probability of something given something. What do you want to say it is?
Probability that the first jelly bean selected is a lemon.
So, lemon given what? So it's a probability of a lemon given you got a lemon already. Now, some of you will go back and look up and say, well, I can see this. Here's why you're seeing that. This would be, in the numerator, if we were breaking it up, the probability of a lemon and a lemon over the probability of a lemon. What would I be multiplying together in order to get what the numerator looks like? Hands up, please, if you can answer that. What would I be multiplying together in order to arrive at lemon and lemon in the numerator? Royce, what do you say? Correct? Now we're going to, I keep doing 36 over here. From now, I need to divide that by the probability of getting a lemon. Looking at that initial setup, what's the probability of getting a lemon? Hands up when you can answer that. We've got two people, seriously. Tommy? Now, Tommy, what do you see in here that means you don't need to go to the calculator? And what's going to reduce out from numerator to denominator? Which is going to leave you with? Does that confirm what you might have hypothesized it was going to be initially? Look back up at the chart. What's the probability of getting a lemon given you already got one? Didn't we label that as 15 out of 35 initially? Now, let's bounce forward a little bit. We're probably going to have to go back. If we have time, we're going to, yeah, go ahead. Question what? Now, the reason that it's going to be different is you're not looking at making some initial condition being met. Like, and it's awkward because there's 2 lemon in that time. Remember how over here we looked at it and said the order like of them didn't matter? You're just going in, and what's the probability that you get 2 lemons? That's the probability of A and B both happening. Do you understand what I'm saying? It's the probability of getting a lemon the first time and then a second lemon. This is saying, what's the probability of getting a lemon, not from the whole set, but given you've already gotten a lemon. You understand what I'm saying? Like an initial condition has already been met. So you don't need 2. You only need this individual probability, not the probability of from here to here. It's the probability of this whole branch versus the probability of just that branch. Do you understand the difference there? Okay? So this one wants the whole branch. A and B both happen. This is saying, what's the probability of B happening given that A has already happened? Okay? Make sense or no? Okay. And I'll tell you right now, again, you will not find a more sympathetic ear when you go through and say this is difficult than I took province stats 1 to the point where this was province stats 1 from SUNY Geneseo back in what day is this? Read it aloud so you can see. Okay. So you can say it's kind of old. So I know what I'm doing. Like you all throw, that's what I love too. Everyone, when you go through at the end of the year, people start throwing their notebooks away. I have no idea as to why. Like I saved all my college notebooks because if you ever need that stuff again, it's sort of going to be there for you. When I need to go through and pull examples, I go through and find what did we do back then. If I need to relearn something, especially something I was terrible at, like computer science, there's another one back there for that. Let's go over to day 5 stuff, because I think, yeah, okay. So we're going to talk about independent and dependent events. There's a test that we can go through and do to figure out if events are independent versus dependent, and there's some testing that we can do on it. An independent event, by the way, just so we're all on the same page, because I don't want to presuppose too much. When we talk about having a single die, that doesn't mean we're telling you to die. That means that we're talking about a single dice. How many sides are on one dice? 6, and they are numbered, okay, 1 through 6. Because somebody said, well, when I use one, the one that we play this game with has like 26 sides on it. No. We're using the same ones that they use in Las Vegas. Now, A and B are independent if knowing that one occurs and does not change the probability of another. That's what that means. Something is independent if the tandem of events occurring does not change the probability that the other one is going to occur. Now, an example of an independent event would be rolling a die and getting a 5, then flipping a coin and getting heads. Does the coin care what the dice did? No. An example of a dependent event is picking cards without replacement. So you probably know that if I call your name from this deck, and I take your name out, or set it near the bottom, what's the probability that you're going to come up next? It's probably going to be really, really slim. If I have a deck of regular cards, and I'm sitting playing poker in Las Vegas, the first card I get is a 4. And I need another 4. Is it more or less likely for me to get a 4 if I already got a 4? Which one? Less likely. Are those events dependent on each other then? And the answer is absolutely yes. There's a way that we can go through and test for independence. There's two ways of doing it. And two events are independent if. Now there's two different ways to do it. I go through and it's sort of, if it's situational, which one you would go through and use. But first thing is compute the probability of B given A if that's equal to the probability of B. The events are independent. And what that would look like in practice is the probability of B and A over the probability of A is going to equal the same as the probability of B. That's one way of trying to prove independence. The other way is to go through and look and say the probability of B and A is equal to the probability of B times the probability of A. If that is true, you have independence. These work easier in practice as opposed to explaining the theory out. Take a look at what you have for question number 1. It says a single die is rolled. Let A be the event a number greater than 3 is rolled. Let B be the event an even number is rolled. Are the events independent? Well, let's start off first and ask this. What are the 6 members of, or successful outcomes for A? What would be your successful outcomes for A? You can tell me what the elements of that set are going to be. 4, 5, and 6. 4, 5, and 6. What are the successful outcomes for B? Hands up, please, if you can tell me the successful outcomes for set B. 2, 4, and 6. Now, if I'm doing this out, there's 2 ways that we can do this. Let's try, I don't know which one I guess is more beneficial. Let's try the one in red. Let's try the one in red. Looking at this, what's the probability, or let's try to prove this, I guess, and judge its truth. What's the probability of getting something that works in B and A? Hands up, please, if you can tell me. What's the probability of getting an event that works in both B and A? Hands up, please, when you can tell me. Look at the sets. What's the probability? You're rolling a dice. What's the probability that the number you get is in B and A? Riley? It's not 2 separate events, it's one's occurring. Which outcomes satisfy both conditions? Yeah. No. You just answered the question. What should it be? 2 out of 6. How many outcomes are in both? You told me, what are the outcomes that are in both? 4 and 6. So that's 2 outcomes out of how many total? When you roll the dice, how many possible outcomes here? 6. Those are the elements that are in both. Now, what's the probability that we get an event that's just in set B? Hands up, please, if you can tell me. You're rolling a dice. What's the probability that you get something from set B? 40. 3 out of 6. Times, what's the probability you get something out of set A? Sean, out. What do you say? Now, let's multiply these together. This is going to be 1/3 is equal to, what's 3/6 times 3/6 going to give you? Questions get tougher. 9 over 18, 9 over 36. What's 9 over 36? Are they equal to each other? No. So are the events independent? Yes or no? The events are not independent. If it was equal, they would be independent from each other, but they are not. Questions on that? We could set it up going the other way as well. Let's try to find some different examples. Let's take a look. Read, and I want you to unpack the question. Before we get to what do I mean by unpack? I mean in the margin of it, I want you to list out every probability that you can determine on the left-hand side of it. So before we go into it, just before you worry about answering this question, I need you to pull all of the given probabilities that we're assuming you know out from that group. What's one probability that we know from this, Grace?
Loud music and hearing problems is 12%.
So the probability that you're in both groups, which means the probability that you have a hearing problem and you listen to loud music is 0.12. What's another bit of information we can pull out from this, Connor? Okay. What else is something that we need to go through and know for this? There's something else that we can go through and statements maybe indirectly arrived at, or there's two ways to go through and find it. What do you want to say?
Probability of listening to loud music and not having hearing problems is
Careful. You're misinterpreting what was said. For this, it just says this. This is what you're referencing, right? So, 85% though were found not to have hearing problems. That's it.
Oh, I thought it was 85% of that.
No. 60% reported that they listen to loud music on headphones, and 85% of the sample that we're looking, which is our total group, were found not to have hearing problems. So I can even say this. Now you said that 85% don't have hearing problems. I went the other way. What's the probability then that someone does have hearing problems, Sam? 15%. Okay. So let's determine if those events are dependent on each other or not. This one sets itself up nicely for the and condition that we used last time. Looking at this, I would go through and say, all right, well, we can figure out the probability of hearing problems and loud music. How did I know that? How would I know what that probability is? They gave it to you. Yeah, it's given. So use that out of the two choices. So we need then to see if that equals the probability of hearing loss times the probability that you listen to loud music. What's the probability that someone has hearing loss and listens to loud music? Amanda? What's the probability that someone has hearing loss? Thomas? And what's the probability that the person listens to loud music? So multiply those together on the right-hand side. And Riley, let us know what you get. Are they equal to each other? No, they're not. So are the events independent from each other? you go. Sure. Because I think the only question that I have is if something like this were to show up on a multiple choice or on the read, I think that they would say not independent as opposed to dependent. But they mean the same thing. Hopefully, if you're familiar with the English language, you understand that those are synonyms of synonyms mean the same thing, right? See, look at me. AP lit, no big deal. Fine. Take a look at the next group. Go through and try out number 3 on your own. This one you can do either way. You can do it as givens, something given something, or you can do it as the and setup. It doesn't matter which one you do, but you've got to do one out of the two. And whichever one our victim picks is the one that we'll go through and do. By the way, I like calling you victims. One of the classroom, and the guy teaches at East High, and they call their children scholars. He said, it's something that's great, it sets a nice tone for your kids. And I said, it would be wonderful if you have a set of kids that try. So I'll call mine victims. Some sort of black widow spider. They're going to get you. And actually, maybe you all. You probably, hopefully aren't, but you're all candidates to be victims this year. Who are you going to be on the lookout and going to avoid receiving harm from this year? Hands up, please, if you can answer that. You've got a couple you've got to be nervous about. What's one group, Connor, that you're nervous about? I'd be more concerned about him. And maybe we need to have a drawing contest, because I don't have a blank question bear up there. We'll give you an extra point or two on your exam if you go through and you give me a good blank question bear. Sure. Give you a point or two on your next exam. But you got to give me, it's got to be good. And we'll have the class, maybe we'll do it on the calculators. We'll pull, is this meritorious of an extra point on the exam? And you can be the judge. I won't even be the judge. We'll have it just for you. And we'll make it anonymous, and we'll have just a thumbs up or thumbs down. You tell me. Now, looking at this, which way did you pick to do it? Nick, you get to pick. Do you want to do it as something given something or something and something? Okay, so it's what and what? So we need probability of snow and rain, and it would have to equal what?
Probability of snow times the probability of rain.
So looking at that, what is the probability of snow and rain? Hands up, please, when you can answer that question. What's the probability of snow and rain? Seriously, 3 people? First, what do you say? Yep. Out of? You're missing one part of it. And do you know what? What is it? What'd you forget to look at? There you go. And it happens all the time. All the time. Next one up. Royce, what's the probability of snow? No. Probability of snow. What is it? What's the probability of rain? Hands up, please, when you can answer that. What? Multiply them together. Are they equal to each other? What did he give us? 11? You're going to get yelled at right now. It's not me. I'm not taking any ownership of it. I delegated. What is it? 13? Now, it's all right. So let it slide. Now we multiply those loves, and what do we get on the right-hand side? Last time I checked, 5 over 31 is not equal to, is it 104 over 961? Are those equal? So are they dependent? Which is an alternate way of saying Let's try, let's look at this one, because this gets fascinating too. That you all start studying, and I love. What are you going to do? Pack up and leave? Get real. Take a look at question A. What's the probability that a person chosen at random is going to be in that group? Hands up when you can answer A. This should take you 4 seconds. If that. What? 89 over 207. Next one up. What's the probability that a person makes over that amount will be 51 years old? What do you have to do in order to get that? What do you have to do in order? We're not leaving until we get this set up for B. What do you have to do in order to answer out B? So what's the B bar? 31 to 45, given you're pulling from the group who makes over 50,000 a year. Okay? Now, I want you to practice this. The way that you're going to practice is as follows. Go to the last homework page on there, which is the last page of your notes. Where is that at? Go through, loves, and we got 45 and 46. I think how many questions are on it? 45 and 46, how many questions? 5 questions. Get real. You can't be bothered to do that? Come on. Be scholars. Be all-stars. You wait. Yes, darling.
I don't think Amanda and I got different answers.
Okay, let's try. Hang on. The homework from last night, which one was this? 4? Hang on, let me just double check. And which day was that? Is it, which one was it? 25? Okay, so this one here. Right? Okay, so let's look at this. What's the probability that a person chosen at random in that age category has an income over that? Okay, so you need the probability that someone has an income over 50,000 given that they are 46 to 60, right? So the way that we're going to do that is the probability of 50
whatever
plus.
they're saying second is really going to come first in this equation.
Yes, and is that what's throwing you off?
I couldn't read it right, and I was like, which
Yeah,
order
it's the
do they
given
go
is
in?
always screwy. It's always
I figured
screwy.
it was backward, and I think that's the way I did it. I just didn't write it out.
So
And
how
I think
many do we
Amanda did
have
it
that
the
are
other way.
50,000 a year plus, which would be 96? That are in both. Sorry, how many are in both? So 50,000, and this would be what? 27 over. How many do we have that are in that band? 53.
Okay, so I did do it right.
I think so.
I think Amanda did them the other way. I think she did this one.
It's got to be.
goes
You
first,
ask,
and
like, think
that's
about
why
it
I
like
just wanna
there's a
make
group
sure.
of everyone. All of these people are now in the room.
Yeah.
Who are you pulling out the first time? What are you sticking around for, Thomas? You can't get enough math? All right. Now, looking at what's there, it says what's the probable person chosen at random is in that category, given that they have an income.
First.
Oh, wait, we're taking the 50, given that they have, so this is backwards. Our setup right now, currently, is backwards. Where did my eraser go? See, it's something given something, right?
Okay.
So, we always look at it and go, what's the given first? So, think about it in terms of a group. Everyone's in the room now. Who are you pulling out to the side first? So it says, what's the probability that a person chosen at random is in this age category, given that they have an income over 50,000? So it's a probability of 46 to 60, given they're at 50,000 plus. See what I'm saying? Who are you making move into the other room first before you do your age count, or before you do your count?
46 to 60.
No.
Wait.
What's the probability that a person chosen at random is in that age category, given
If they already make over.
if they already make over that?
So the people with 50,000, you're taking them first.
I'm taking everyone that makes 50 grand, I'm taking them over to Miss Bailey's, and then we're computing our probability, not from the whole group. So this would be the probability of both over the probability of 50K. So that would be 27 over. Now, how many do we have over 50K? 96 now.
Okay.
Do you see how that's different?
Yeah.
Okay. It's going to be tough. You've got to go through and say which one is the given. Okay? Don't, please, I personally am sympathetic because I'm not a reader.
I keep messing up. I made them all backwards.
It's all right. We're going to learn, aren't we? Good.